In this video, we are going to talk about the future of automated construction. So before starting this video, please like this video, and subscribe to our channel for the future updates. Borja Garcia de Soto, Assistant Professor of Civil and Urban Engineering at NYU Abu Dhabi and Director of the S.M.A.R.T. Construction Research Project, says that where we are with construction robotics doesn't have a simple response. According to Dr. Maja Matari, author of the Robotics Primer, robots are an autonomous machine that exists in the physical world, can sense its environment, and can act on it to achieve certain goals. The construction industry still struggles to pass the prototype and testing stages. The use of single-task robots, STR, in the construction industry, on the other hand, has been on the rise for some time. Robots are now widely used in processes like production, testing, and control, states Mark Ireland, Chief Engineer, Technology Strategy, for the Manufacturing Technology Center, MTC. When you consider the full scope of robotics and automation, there is a lot of work being done right now, especially in the areas of design automation and the use of industrial automation in the off-site manufacturing of sub-assemblies. There is also a lot of work being done in the infrastructure field on robotics and automation, which will aid in the completion of complex, time-consuming activities that would otherwise have to be performed manually. This includes everything from surveying drones to pipe inspection drones to underwater inspection drones. Various concepts, designs, and early implementations continue to show how robots can help with building. The position of robots in construction is expected to expand as researchers, academics, and technology companies continue to push the boundaries. For decades, the manufacturing industry has used robotic automation extensively. The majority of automobiles, consumer electronics, and even domestic robots were designed and assembled by armies of robots with little human oversight. Higher output efficiency, a safer working climate, lower costs, and better quality are all benefits of robotic automation. The method now needs minimal human intervention after years of production and implementation. Let's start. Midway on the journey from manual construction to full automation. Ancient Egyptian temples and pyramids continue to fascinate, not just because of their sheer scale, but also because of the techniques used to construct them. To assist construction, simple devices such as the ramp and the lever were invented. The mode of construction hasn't changed much over thousands of years. It remains a labor-intensive industry, aided by non-automated devices that are much more sophisticated and powerful than those of the past. The construction industry is confronted with a number of issues, including worker safety and expense, as well as stricter environmental regulations. An aging population has resulted in fewer jobs and more workplace accidents around the world. As a result, more funds are needed to pay increased wages, insurance costs, and workplace safety training and equipment. In the 1960s, industrial robots became popular. The Unimate robotic manipulator, which has 6 degrees of freedom and can handle items weighing up to 500 pounds, has been unveiled. It paved the way for complete assembly line automation. Over the last 2 decades, the number of industrial robots in use has increased threefold to 2.25 million. From 1993 to 2016, robotics investment accounted for 10% of OECD countries' GDP growth per capita. Despite the apparent advantages, the building industry has been slow to adopt automation. It is undeniable that an automated robotic device reduces labor and manufacturing costs. According to a McKinsey report, manufacturing labor compensation in the United States is 4 times the average robot price. However, financial gain is insufficient to propel the building industry forward. There are plenty more challenges to overcome. Robots in industry typically work in well-defined and predictable indoor environments, confined to a fixed assembly line or working space to complete assigned tasks. It's a whole different story in the building industry. Construction sites are rife with surprises and ambiguity. Workers are required to operate in a variety of conditions, including rainy and dry, hot and cold, sandy and watery, and open and confined spaces. The building robot inventors face enormous technical challenges. Making a robot that can do it all and adjust to these varying operating conditions would be prohibitively expensive. Construction automation is often hampered by long-standing rules and complicated procedures. There are complex and often harsh laws in place to ensure the quality and safety of construction work. The legal obligation of employees specified in contracts, as well as professional certification tests, include safety guarantees. How can these conditions be enforced on robots if they replace human workers? Who will be held liable for any faulty work or accidents? In the field of architecture, there is a notable chasm in robotics ethics. Robotic technology adoption is often limited by the difficulty of construction tasks. Hundreds of activities and stages are normally included in a building project. While we have sophisticated robots for specific tasks, we have yet to develop a fully automated management system. It's like having a star-studded football team without a professional boss. The implementation of such a system necessitates a thorough understanding of construction management and process flow, but there are few studies and scientific models available. Many individual activities on construction sites could be automated over the next 10 to 20 years. However, there is still a long way to go before full automation is achieved. Advantages of introducing robotics and automation into the construction industry. Robotic technology is still a topic of discussion in discussions about the future of building and architecture. It can be used to address some of the industry's long-standing concerns. During the 1980s, robotics technology advanced quickly, especially in Japan, to address labor shortages caused by an aging workforce and younger workers' aversion to hard physical labor. Every developing country and area is now dealing with the issue of aging. The median age of construction workers in the United States increased from 37.9 in 2000 to 40.4 in 2010. Since older workers' injuries are more serious, compensation rates rise with their age. Over the course of a 45-year career, a construction worker has a 75% risk of suffering a crippling injury and a 1 in 200 chance of dying on the job. Robots are hoped to be able to perform both high-risk activities, such as demolition and working at heights, as well as fill labor shortages in particular professional tasks. Robots are more appealing than human workers in the future because they can work around the clock and without errors. Humans aren't robots. Fatigue is an inherent weakness, and as a result, errors and inconsistent quality are common in their work. Robots, on the other hand, are not fatigued and can perform the same task with high precision and accuracy. Finally, the most underappreciated but most important advantage of robotics and automation in construction is the expansion of design options. Architects have a limitless supply of design proposals, but in the real world, considerations such as worker methods, time, and construction costs must be considered, all of which obstruct the realization of imaginative concepts. Completely autonomous robotics may eliminate at least some of these constraints, allowing for the construction of more complex, artistic structures in the future. Construction robots can revolutionize the future of the building industry. The research team from the Faculty of Engineering and Professor Adam Fingrut from the School of Architecture at the Chinese University of Hong Kong, CUHK, introduced CU-Brick, a cable-driven robot that builds with Jenga blocks, at the Hong Kong Bi-City Biennale of Urbanism, Architecture 2017. The Jenga blocks had to be positioned precisely at assigned locations with a very limited margin of error due to the irregular layout of the buildings. With the idea of creation possibilities are infinite, this project illustrates how robotics can assist in realizing the architect's vision. The CU-Brick robot is compact, allowing the system's actuators to be installed on metal frameworks to the walls and roofs of buildings in a variety of settings, allowing for larger-scale three-dimensional construction that would otherwise be impossible to achieve. The machine software calculates and monitors the cable pulling, allowing the gripper to move accurately and position bricks. Our team is currently working on another building construction-related project, developing a high-rise facade operations robot. Rather than being a device that expands the range of possibilities for new brick structure designs, the facade robot seeks to solve a major problem in the building construction and maintenance industry, removing staff from dangerously high places. The device is designed to handle a variety of tasks, including window washing, facade decoration, and maintenance work. Currently, such work is carried out by humans on gondolas, which are both risky and costly to run. As a result, we are not developing robots to replace human jobs, but rather to provide them with a safer working environment. We will show the practicality and efficacy of our robot on a facade at CUHK in the coming year. Thanks to an aging population, the industry has started to acknowledge the need for more exposure to automation robotics. Companies are constantly pursuing collaborations and opportunities to commercialize robotic technologies and adapt them to the workplace, which will further speed up automation within the industry, thanks to good research work undertaken by research institutes and the help of governmental bodies. What do you think of our video? Let me know in the comment section below. If you enjoy this video and want to hear from me again, be sure to hit that subscribe button before you go. Thanks for watching.